Good morning everyone. In this particular video lecture, we are going to discuss regarding the parallel RLC circuit. Now my dear friends, as you can see here, basically in the given circuit, there are three elements connected in parallel to each other. As you can see here, this one is resistor, this one is inductor, and this one is basically capacitor. And my dear friends, here the overall current is denoted by I, and the supply voltage is denoted by V is equal to Vm sin omega t. Now my dear friends, as we move further, then as you can see here, as we know, the voltage across resistor is basically I into R. And now if we talk regarding the current, then the value of current across resistor will be V by R. And because the angle between the voltage and current in case of resistor is basically we can say 0 degree. So here my dear friends, as you can see here, the current is equal to basically V by R at angle 0 degree. And now my dear friends, as you can see here, in the same way, basically the current across inductor, that is IL, will be basically V by XL at the angle minus 90 degree. And if you want to calculate the value of current across capacitor, then that will basically comes out to be, as you can see here, V by XC at the rate plus 90 degree. Now my dear friends, as you can see here, after applying KCL at node, basically as you can see here, the overall current will be basically the summation of current across resistor, the current across inductor, and the current across capacitor. Now my dear friends, we will now put the all these value of current, that is the value of IR is equal to V by R, the value of IL is equal to V by JXL, and the value of IC is equal to minus V by JXC. Now my dear friends, after putting all these value, we will basically take V as a common, then our equation basically will be comes out to be something like this. And again basically from both these two terms we will take minus J as common, then our whole equation will basically comes out to be I is equal to V into 1 by R minus J into 1 by XL minus 1 by XC. Now my dear friends, as you can see here, as you proceed further, I by V will be equal to, my dear friends, 1 by R minus J into 1 by XL minus 1 by XC. And my dear friends, we know that basically that resistance is equal to, basically we know that V by I. So here basically we can say that the whole equation will be equal to 1 by R, my dear friends. Means we can say basically the reciprocal of impedance. And here the whole equation is denoted by Y, that is admittance, my dear friends. Now my dear friends, as we move further, then from here we can calculate that I is equal to V into admittance. And now as you can see here, admittance Y is equal to 1 by R minus J into 1 by XL minus XC. Now my dear friends, as we move further, then as you can see here, basically we know that 1 by R is basically denoted by G, that is conductance, which is basically equal to the reciprocal of resistance, we can say. And now my dear friends, basically J into 1 by XL is basically denoted by BL, and 1 by XC is basically denoted here BC. Now my dear friends, we will now proceed to draw the phasor diagram basically. And for the construction of phasor diagram, there will be basically three different cases. The first case will be the phasor diagram in case where IL means inductive current is greater than IC, and the second case will be basically we can say IC is greater than IL, and the third case will be if IL is equal to IC, my dear friends. So my dear friends, the first case we will discuss the first case, that is if IL means inductive current is greater than capacitive current. Now my dear friends, if inductive current will be greater than capacitive current, then as you can see here, basically for the construction of phasor diagram in parallel circuit, voltage is taken as reference, and then we know that in resistor the current is in same phase. In case of resistor, the current will be in same phase to the voltage. Now my dear friends, we also know that in case of capacitor, basically this is voltage and the current will basically lead by 90 degree. So this will be basically, my dear friend, IC. And if we talk regarding the inductor, then as we know, basically the current lags in case of inductor to the voltage by 90 degree. So this will be basically, my dear friends, IL. Now my dear friends, we will basically move to the next thing, that is here the case is basically IL is greater than IC. So my dear friends, as you can see here, basically this part is denoted by, we can say, IL minus IC. So my dear friends, as you can see here, the next equation is basically current, that is I is equal to IR minus J into IL minus XC. And from here, if you want to calculate the magnitude of current, then that will basically comes out to be root under IR square minus IC minus we can say IL minus IC ka whole square. And from the same we can say the phasor diagram we will draw, basically we will find the value of tan phi, and basically we can say the value of power factor. And my dear friends, as you can see here, the inductive current is greater than, we can say, capacitive current. So my dear friends, in this case the overall circuit will be lagging in nature, we can say, due to the presence of mode, we can say, effect of inductor. Now my dear friends, we will move to the next case, that is IC, means inductive current is greater than we can say inductive current is less than capacitive current. So my dear friends, the next case will be, as you can see here, the phasor diagram will be same, only the basically the IC minus IL part will be above the, we can say, the horizontal axis. So my dear friends, in this case also, if you want to calculate the value of I, then that will basically equals to IR plus J into IC minus IL. And if you want to calculate its magnitude, then that will basically equals to root under IR square plus IC minus IL whole square. In the same case, my dear friends, if you want to calculate the value of tan phi from this triangle, then that will basically comes out to be IC minus IL by R. And from here we can easily calculate the value of cos factor, cos phi, that is power factor. Now my dear friends, here in this case, basically the capacitive current, that is IC, is greater than IL. So my dear friends, we can say that basically this the circuit in this case will be basically leading in nature. And now my dear friends, the case third, that is IC is equal to, we can say, IL. And now in this basically case, our equivalent current will be equal to IR, that is resistive current, and here the phasor angle will be 0. And if phasor angle is 0, then basically we can say that the power factor will be cos phi, that is, we can say, means unity power factor. And now my dear friends, this case is also known as resonance concept, because in parallel resonance, basically the same case basically occurs, that the power factor is basically comes out to be 1, that is unity power factor. So here, due to the unity power factor, we can say it as, or we can say, resonance concept. Now my dear friends, we will basically draw the admittance triangle. Now basically we have derived this relation earlier, and by using this relation we will basically draw admittance triangle. From here we can say that admittance is equal to reciprocal of we can say impedance, and this is basically the inductive susceptance, and this is basically the, we can say, capacitive susceptance. And here BL is equal to 1 by XL at the angle minus 90 degree. And we can say that BC means inductive capacitive susceptance is equal to 1 by XC at the rate angle 90 degree. Now my dear friends, here also basically there will be three cases. The first case will be basically if the inductive susceptance is greater than capacitive susceptance, and in that case basically, my dear friends, as you can see here, this is basically the resistive part, this one is basically the capacity part, and this one is basically the inductive part, same as that of phasor diagram. So my dear friends, here the case is means the capacity part, that is BL, is greater than BC. So here this will be basically BL minus BC part, and from the same triangle we can easily calculate, my dear friends, the value of tan phi and power factor. And because, my dear friends, here you can say that the basically the, we can say, inductive susceptance is greater than capacitive susceptance, so here the effect of inductor will be greater than the effect of capacitor. So my dear friends, the overall circuit in this case will be lagging in nature. Now my dear friends, we will discuss the next case, that is the, we can say, BC is greater than, we can say, BL. Now my dear friends, we know that basically this is the reference voltage, and below this there will be basically, we can say, the inductive part, and above it there will be basically we can say that capacity part. And on the same axis, that is on the axis of voltage, there will be, we can say, that is basically, we can say, admittance, we can say, my dear friend, admittance. So my dear friends, in this case, if you want to draw the phasor diagram, then basically here there will be basically BC minus BL part, as you can see here in the diagram. Basically this one, as you can see here, basically this one is our BC minus BL part. Now my dear friends, from this triangle we can easily basically calculate the value of phi and cos factor, power factor. Now my dear friends, basically as you can see here, in this case the value of capacitive we can say characteristics is greater than we can say inductive characteristics. So in this case the overall circuit will be basically capacitive in nature. Now my dear friends, we will basically discuss the next case, that is last one, that is as you can see here. In this case basically the inductive susceptance is equal to capacitive susceptance. So now in this case my dear friends, the value of Y, that is we can say the admittance, is equal to G, my dear friends, as you can see here. And here in this case will be basically my dear friends phi, that is the power factor angle will be 0, and so here power factor will be unity power factor, that is the resonance concept, my dear friends. Now we will discuss the next thing, that is power triangle. My dear friends, as we know that basically there are three cases in drawing phasor diagram and in admittance triangle. So basically here there will be also the three case, that is the case first is if QL is greater than QC, then the second case will be if QC is greater than we can say QL, and the last case will be if QC is equal to QL, my dear friends, QL. So my dear friends, this is basically the first case. And now as we know that the value of current is equal to IR minus J into 1 by IL minus IC. Now my dear friends, we know that power is equal to voltage into current, and here the value of basically current is given. So if we multiply both side the current equation by voltage, then basically we will get the power equation. So my dear friends, after multiplying we can say that V by I is denoted by S, V into IR is denoted by P, and we can say that J into VIL minus VIC is denoted by basically my dear friends, as you can see here, this V into IL is denoted by QL and V into IC is denoted by QC, my dear friends. Now my dear friends, from here if you want to calculate the magnitude of S, then as you can see here basically S will be root under P square plus QL minus QC whole square. And my dear friends, from this triangle, as you can see here, from this triangle we can easily calculate the value of power factor and tan phi. Now my dear friends, we will move to the next topic. Next we can say next case, that is QC is greater than QL. Now in this case my dear friends, this one basically, this will be basically the QC minus QL part, and in the same way my dear friends, we can easily calculate the value of magnitude of S and basically we can say power factor. Now my dear friends, one thing here to be noted is that in this case my dear friends, in this case the circuit will be basically lagging in nature, because the inductive effect here is greater than the capacitive effect. Now my dear friends, if we talk to the next we can say case, so in this case my dear friends, the capacitive effect, as you can see here, the capacitive effect, that is QC is greater than we can say my dear friends QL. So my dear friends, in this case basically our circuit will be we can say leading in nature, or our power factor will be leading in nature. Now my dear friends, we will move to the next topic, that is we can say my dear friends the case number third. In case number third, my dear friends, as you can see here, the value of QL and QC will be equal, and if these two values are equal, then basically the value of S will be equal to P and the power factor angle will be equal to 0, due to which our cos phi, that is power factor, will be equal to 1, that is unity power factor, and this is basically also the resonance case. So my dear friends, in this particular video lecture we will basically discuss regarding the parallel RLC circuit. So my dear friends, this was all regarding the we can say parallel RLC circuit. I hope you have enjoyed this video. That's all. Thank you.